Hello guys, welcome back. Here we have another question from GATE EC 2017 on network theory. So in the circuit shown, the voltage V in of t is described by V in of t is equal to 0 for t less than 0 and 15 volts for t greater than or equal to 0. So this is the circuit. So the input is V in of t and then we have 1 ohm resistance and we have two inductors in parallel. So the time in seconds at which the current I in the circuit will reach the value 2 amperes is dash. So this is slightly different from normal questions only in the fact that here they are given two inductors instead of one. Otherwise all the calculations, everything will be straightforward, similar to a single R single L system. So let us take this. So let us forget about this I know. So if we have to combine these two, how will we have it? So this 1 ohm will be there and the inductors in parallel, it will be similar to the resistors, right? So effectively this will be 1 into 2 by 1 plus 2. So this is 2 by 3 Henry. And then we have V in of t. So if it was a capacitor in parallel, we need to add them, right? Because capacitor, the inductance is inversely proportional to C. The impedance, I mean. Okay, so now we have this circuit. Let me call this as some I dash. So what is my V in of t? My V in of t is 0 to 15 volts, right? At time t equal to 0. So what will be my I dash? So first let me find I dash of 0 minus. So for 0 minus, it is 0 by 1 ohm, which is nothing but 0 ampere, right? And I dash of infinity is, so when it tends to infinity, your inductor will act like a short circuit and your current will be 15 by 1 ohm, which is 15 ampere. And if you see, this is a single RL circuit. So the time constant is given by L by R. So what is your L here? It is 2 by 3 and your R is 1 ohm. So time constant is 2 by 3 seconds. So how will your I dash equation look like? So initially it is 0 and finally it is 15. So 0 into e power minus t by tau plus 15 into 1 minus e power minus t by tau. So I dash of t is 15 into 1 minus e power minus 3t by 2. So next step we have to do is we have to find the relation between I and I dash. So let me take this. So this is your I and this is your I dash. So this is similar to your resistive divider, right? So just imagine these as resistors of 1 ohm and 2 ohm because the ratios are same 1 is to 2. So how will you write I in terms of I dash? I is nothing but 1 divided by 1 plus 2 into I dash, right? So I is equal to I dash by 3. So why is it so? If you see this, this is 2 ohm and 1 ohm. So 2 by third of the current flows through this 1 ohm and only 1/3 of the current is flowing through this 2 ohm. Similarly, it is the same case for inductor. But on the other hand, if it was a capacitor, so if you see, if it is 1 farad and 2 farad, and this is I dash and I. So here it is directly proportional. So I is equal to 2 by 1 plus 2 into I dash. So you need to keep that in mind. So why is this the case for capacitor? Because capacitor, the charge going into the capacitor is equal to C dV by dt, right? So here if you see in parallel combination, your V is fixed. So your Q1 is equal to C1 dV by dt. Your Q2 is equal to C2 dV by dt. And your I1 and I2 are nothing but d by dt of this. So this will be like this. So now if you see, your I is directly proportional to your C. On the other hand, if for the inductor, if you see, what equation you have? V is equal to L di by dt. Here again your V is same. So L1 d1 and V is equal to L2 di2 by dt. So now if you see for the current I1, let's say di1 by dt. If you see it is V by L1. So it is inversely proportional to L1. Similarly di2 by dt is V by L2. So your effective di by dt, this is your I bar, what we have assumed, right? It is equal to V into 1 by L1 plus 1 by L2. So this is nothing but your similar to your parallel combination of resistors. So that is why we were doing in that way. Okay. So now for this question, this one we don't need it. So coming back here, we got the relation between I and I bar, right? I dash. So your I is equal to 15 by 3, 5 into 1 minus e power minus 3t by 2. So now you want the t such that this is equal to 2 amperes. So this is equal to 2. So 1 minus e power minus 3t by 2 is equal to 2 by 5. So if you bring it this side and subtract, it will be 3 by 5 is equal to e power minus 3t by 2. So take natural logarithm on both sides. Ln of 3 by 5 is equal to minus 3t by 2. Your t is equal to 2 by 3 ln of, or minus 2 by 3 ln of 3 by 5. So this is equal to 0.34 seconds. So while using calculator, you should be careful to take this as natural logarithm. Your log will be to base 10. So this is base 10. Natural logarithm is base e. Okay. So this question, your answer is 0.34 seconds.